Now that we've learned how to add some of the more baseline definitions to our model, let's start adding actual physical objects to it. New workbook. New button. Let's add a new createFrame macro. With this macro, we'll be adding a new frame object to our model. For this, let's look at the SAP 2000 API. We'll find the required function under API Functions, Object Model, and Frame Object. Here, we have the AddByCoord function that we'll use. This function requires start and end XYZ coordinates for the frame object, as well as the object name and section name. So, let's add space for those to the worksheet. Let's call it frame1 and let's give it the fsec1 frame section, which is created by default whenever we create new objects, and no frame section has been defined yet. Okay, since this macro is quite similar to the ones we've seen previously, we'll speed through most of it as there's not much to talk about except at the end. Finally, let's refresh the SAP 2000 view. Sometimes, when we add new objects to our model through the API, SAP 2000 doesn't immediately refresh its views. So, it looks like we haven't added any objects at all. That should be it. Let's run our code. Let's look at our SAP 2000 instance. There is our new frame object. That was quite short. So, let's add an area object and be done with our general introduction to the SAP 2000 API functions. The function we'll need is in the area object folder. Here, we'll find a similar AddByCoord function. But this one is a bit different. This one, we can see, draws an area object using a polygon that's defined by a number of points and 3 arrays of XYZ coordinates that hold the point coordinates. So let's create a new button with a new macro called createAreaObject. But this time we'll do something different. We'll prepare our worksheet to input any number of values for our polygon coordinates. For this function, we'll ignore the object name and the area section name as these can be omitted and assumed as default by the API. We'll now copy the previous macro, and we'll define the array variables for the polygon coordinates. In VBA, to define an array variable, we simply need to open and close parentheses after the variable name. Just a couple of remarks about this. The first thing we should mention is that, if we were to put a number here between parentheses, this would define a static array, which is an array that has a fixed number of entries. The number would be the last valid position of the array. So, for example, if we wanted an array with 3 values, we would put the number 2 between parentheses. Secondly, we're not defining a static array because we don't know how many values our array needs to hold at this point. And, even if we did, the SAP 2000 API works best with dynamic arrays. Dynamic arrays, as opposed to fixed arrays, have a variable number of values and they can be defined by leaving the parentheses empty. With this said, let's declare our coordinate arrays. Now, before we fill our array, we need to figure out how many values we'll need to reserve for it. For this, we can declare a counter variable, starting it at 0. and then adding a simple while cycle that starts at the first point coordinate cell and goes down the column until it encounters an empty cell, incrementing our counter on the way. And now, we can finally resize our dynamic array. All we need to do is use the ReDim keyword while stating the new array maximum index explicitly. Next, we'll do a for cycle that goes up to our count value, -1, to fill our coordinate arrays. For cycles and while cycles are quite similar, but for cycles are used when you already know how many cycles you'll be doing beforehand. Conversely, while cycles are better for when you're not sure how many cycles you have to do and need to check a condition before executing a new cycle. That should be it. Let's pass our coordinate arrays to the function. One last thing of note before we test it out. When using the SAP 2000 API, even if you're using arrays that should, logically, have fixed sizes, such as an array with 3 entries for coordinates of a point, it's a good idea to set their size with a ReDim anyway. Sometimes, the SAP 2000 API may be expecting a dynamic array internally and will send out an error when that is not the case. Okay, let's put some coordinates into our worksheet and see what we get. Great! As you can see, we can easily create an area object with a complex shape quite easily this way. This concludes the introduction section of this course. Now that we have all the required information on handling SAP 2000 instances, adding definitions and object to SAP 2000, as well as general concepts of VBA and Excel interaction, we'll now move on to making a basic model template, similar to what SAP 2000 offers when you open a new file. After this, we'll learn how to make our own custom template that's highly flexible and able to be set up with more detail and completion than what SAP 2000 offers with just the default template options.